Hello, ladies and gentlemen. Let's look at some practice solving for Newton's second law. As you guys know, the equation is force equals mass times acceleration, where force is always in newtons, mass is always in kilograms, and acceleration is in meters per second squared. Okay? So I'm going to model exactly how these problems should look like when you're doing them on an assessment or just on homework. All right? So let's look at the problem. It says, suppose you were using a 10-kilogram bowling ball at fast lane. With what force would you have to roll the ball for it to accelerate down an alley at 2 meters per second squared? Use F equals ma in your response and show your work. So every time we're going to write down the equation, force equals mass times acceleration. We're also going to write down what is given in the equation. What do we know about what's given? So we know that the bowling ball has a mass of 10 kilograms. And we know that we want it to accelerate down the alley at 2 meters per second squared. So we are going to place these known values into our equation. So we know the mass, it's 10, so we're going to put that in place for the mass. And then we know the acceleration, it is 2. So when we multiply the mass times the acceleration, we get 20. Now, 20 what? What is the unit? Well, we're finding force, and we know that force always has a unit of newtons. Okay, so this should all be here. You are showing what you know from the problem. You're writing the equation, showing your work, and then showing your answer, including units. All right, let's try another one. So now suppose you want to use a bigger bowling ball. So this time the bowling ball is going to be 15 kilograms. So that's the mass. We still want to accelerate at 2 meters per second squared. All right, so once again, we are going to write down the formula. F equals mass times acceleration. So what can we fit in? We know the mass is 15 kilograms. We know we want it to accelerate at 2 meters per second squared. So when we multiply those together, we get 30, and again, it's force, so 30 newtons. Now notice, we had a more massive bowling ball in our second problem, right? The mass of the first one was only 10 kilograms, and the second one was 15 kilograms. So does it make sense that we would have to use more force to accelerate that second ball? It should make sense because that second ball has more mass, right? We know that's part of the relationship of Newton's second law, that when something has a bigger mass, you're going to have to use more force to accelerate it. All right, let's try one more. So not all of these problems are going to solve for force. So let's try a different one. Picture yourself at Memorial Park playing baseball. You hit a baseball that has a mass of 0.5 kilograms with a force of 25 newtons. What is the acceleration of the baseball? All right, so once again, we're going to write down what we know. So the mass of the baseball is 0.50 kilograms, and the force that we hit it with is 25 newtons. Sorry, you can't really see that. Now, we're going to write down our equation. I'll just do it below. So F equals ma. So the force is 25 newtons. So we're going to stick that in here for force. And what else do we know? We know the mass. It's 0.50 newtons times, what do we have left? The acceleration. That's what we're looking for. So how do we get acceleration by itself? We're going to need to do what to both sides? We're going to need to divide both sides by 0.5. So those will cancel out. And if we divide this by 0.5, what are we going to get? So if you need a calculator, use that. Tell me what you get. You should get 50 is the acceleration. And what's our unit? For acceleration is always meters per second squared. Now, if you don't like solving this way, you can always rearrange your equation. So we know that we're looking for the acceleration. So if you would like to rearrange your equation, F equals ma, if you want to solve for acceleration, you would divide both sides by m, right? So acceleration would be equal to force divided by mass. So if you'd like to do that, you're going to get the same answer. You can see that the force is 25 and the mass is 0.5. So the answer is the same, but if this makes more sense to you, then feel free to do it that way. Just still make sure and show your work, please. I hope this helps.